To start, I would like to invite to Professor Chris Rorden with his talk, NiiVue, Modular Neuroimaging Sensitization Based on Web Technologies. Dr. Chris Rorden leads the neuroimaging core for the Center for the Study of Aphasia Recovery. He has spent his career using brain imaging to understand the consequence of stroke. He has developed tools for imaging conversion, DICOM techniques, visualization, MRITogether2024-S10T1, and statistics, NiiStat. So, Chris, please, the stage is yours.
Hello, everyone. I'm Chris Rorden, and I'm presenting on behalf of my team, which includes Chris Drake, Taylor Hanite, Franco Pastelli, and Dan Levitas. But I'm also going to mention quite a few of the other people that we've collaborated with. And what we're really trying to do is create a community-based neuroimaging-specific visualization tool based on web technologies. And it's worth saying what our motivation for doing this is. And already in this series of talks, we've heard entire section talking about the reproducibility of neuroimaging and the importance of reproducibility. And a lot of the emphasis on those talks were how we should really think about having large data sets so that we had good statistical power. But I think as crucially, neuroimaging is really expensive to acquire, and the effect sizes we're looking for are quite small, and these effects can be completely swamped by artifacts. And so even though our automated pipelines for handling data are generally quite robust, when they fail, they can tremendously contaminate our data and really influence our ability to find real effects. And given the costs that go into neuroimaging, these are things we really need to be careful of. And so my cartoon here kind of emphasizes my view of this, that if you think about a self-driving car, in general, self-driving cars are really good, and they will get us most of the places, but occasionally they need a human to intervene to stop you from having a catastrophic error. In the same way, I would argue that in neuroimaging, visualization and human interaction and being able to check that everything is going right is really important. And it's important in every single stage of neuroimaging. So on the left, you can see when we acquire our data, visual inspection helps us identify and ameliorate a lot of the common artifacts that we'll see with acquisition. In the pre-processing steps, there's lots of different steps where we can have artifacts that aren't really what we want. The unwarping can work incorrectly, the segmentation may not be right. We may want to refine regions of interest through drawing or check our registration. And again, visual inspection really helps us make sure that the tools we're using have converged on the right answer. And then finally, in terms of inference and dissemination, being able to understand in the complex shape of the brain where we're seeing effects and where they're happening is really important. So I would say the term neuroimaging already, the name itself is a hint at the fact that we're fundamentally imaging-based technology, that visualization plays this core role. And I would argue that there's a real opportunity here to try to create a community-based visualization technology using web tools. And we really need domain-specific tools. So it's worth saying that we can't just use off-the-shelf image tools like Photoshop or Illustrator or Blender for the type of neuroimaging data, because we have a very bespoke, specific type of data we work with. We work with raw data that's three-dimensional voxels. We derive streamlines from this. We derive connectome maps, we derive meshes, and we derive a lot of statistical maps from this. And so we really want to start thinking about the specialized tools and the specialized ways that we use imaging in our field. So there's really a need for bespoke tools. And the good news is there are a lot of free tools that are available. On the other hand, I would argue that the popular tools that are available are all have similar limitations. And one limitation is they're all desktop-based. So as we start moving to larger analyses where we want to use cloud and edge-based techniques, these tools are not suitable. But also because a lot of these tools try to do every single task that a user might want to do, the user interfaces tend to be quite clumsy and almost overwhelming and daunting. And that's particularly challenging for users because as you start becoming familiar with one tool, it's very hard to use a different group's tools because you've gotten used to the complicated user interface of the tool that you're familiar with. And in addition, each one of the groups tends to have their own private formats for dealing with things like statistics and meshes. And so they deal with their own subformats. And so the different tools that we have tend not to play well together. And so those are some clear limitations with the tools that we have available to us now. And so my vision statement is, what we're trying to say is this is an opportunity that we have all these different devices that work quite differently and may be suitable for different tasks. So you could think about a tablet is really nice for drawing things on. It has a good pencil interface. We do a lot of our work on computers, but also if we have a problem and we want to get expert advice from a radiologist or some other expert or a PI on a grant, it's nice to be able to send data to a phone and have someone who has a phone be able to look at these outputs. And so what we're really looking for is a universal tool that can work on the web. Anyone can install it regardless of what type of device, what type of operating system. They don't have to actually really install anything as long as they can open a web page, and they can work with any device that they have available. And so what we've really tried to strive for is a community data, a community-driven visualization. We certainly aren't the first tool that tries to bring neuroimaging visualization to the web. And there's been a lot of seminal tools. And I would say that we're trying to use a set of technologies that have just been released. So we're trying to use technologies that we think really give us the full stack of the type of tools that we need. But I think the most important thing is we try to leverage the collective wisdom of a lot of teams that traditionally you would think of as being competing with each other. And teams like AFNI and FSL, who've all been training a lot of individuals, FreeSurfer, they know what the pain points are for a lot of different users, but they've been developing their own tools and then using their collective wisdom to say, well, really, what do we need and how can we support all of your different formats so that we can work together and we can have one tool that will work with all the different devices. And so we've really tried to embrace this community outreach with a lot of different teams. And so what I want to do in the next few slides is just to highlight a few use cases from these different groups of how we can embed visualization into pre-existing groups pipelines. And this is definitely a very selective list, and I'm not intentionally dismissing some of these other groups whose icons are shown here, but given space limitations and also the fact that I want to talk about contributions and outreach, I'm going to give just a short taster test of some of the different tools that are using this. And so one neat tool that we developed is this idea of doing imaging on the edge, of being able to actually print objects, make printable objects on the web using artificial intelligence. So we've already realized, anyone who's used ChatGPT has realized how influential artificial intelligence is. And we've also seen how artificial intelligence can do a lot of amazing neuroimaging tasks remarkably well. So topics like tissue segmentation, topics like parceling the brain into different regions, brain extraction. These are all tools that we can do very nicely using AI. But a lot of AI tools are really hard to deploy because they require NVIDIA CUDA, a very specific pipeline of PyTorch specific versions. There's lots of dependencies, and deploying these tools can be quite challenging. And so one of the ideas, and this was really something from the BrainChop group that really had this innovation of, we can use tools like Onyx or TensorFlow.js to actually have the compute done on the user's own web page. And so the user themselves are the people who are going to apply the processing. And these AI models can use that user's graphics cards. And by using WebGL and WebGPU, it will work on any graphics card. They don't have to install any software. If they're supporting modern web technologies, their computer will be able to segment the brain. And then we said, well, let's actually try to solve a problem, create a complete tool chain. So think about a lot of people who might come to your brain imaging center and they get a scan of their brain and they'd like to 3D print your brain. And we thought, wouldn't it be nice, instead of having to tell them that they have to install FreeSurfer, that requires a certain license, they can only run it on Linux, they have to use another tool to turn it into a mesh, they have to clean the mess. What if we could do that all on a simple web page? So I'm going to show you kind of how this looks like. So if you go to brain2print.org, and you can drag and drop any brain you want so that the tool will read brains as you drag and drop them. And then you can choose from a host of different AI models. And so here it's found the brain. And that looks like a pretty good job. So I'm happy with that model. And then I can decide to create a mesh. And I can decide, do I want to hollow mesh, which requires less material in 3D printing, or do I want a solid mesh? I can simply apply and I can check and make sure that the mesh it shows me is one I like. And if I'm happy with this, I can save the image. And all of this is happening without cloud technologies. It's all happening on the edge on my own computer. And so that's really nice for a user for several perspectives. From the user's point of view, unlike a cloud, there's no privacy problems. I'm not sharing my image to the cloud. Everything's happening locally. And me as a developer, it has a huge advantage because if I were to provide this as a cloud-based tool, I would have a huge problem if my tool became popular. Because if 1,000 users wanted to use my segmentation tool, it would overwhelm my resources and I'd have to allocate for all that. The beautiful thing with edge tools is every time I get a new user, I'm actually getting a new computer, right? So we're able to scale perfectly with this edge computing. So I think this is a really nice showcase of how we can use web technologies. No one has to download any software. As long as they can open a web page and their computers follow modern web technologies, they can have an end-to-end solution to 3D print their brains. With the BrainLife team, they have a beautiful bid system that will do a lot of automated processing, this time using the cloud. And then the question is, how do we import data into the cloud? And so they've created a tool, Easy Bids, that uses my own DCM to NICs that will take DICOM images and extract them and help guide users through it. And our web technology visualization is a nice way to make sure, have I actually defaced the image? Have I removed the private information from this image where I'm comfortable sharing this data set with others? And so, again, visualization can play that really important role in this task of sharing data and making sure that the data looks correct when you create a BIDS data set to share. AFNI is a really popular pipeline for processing data. And what we've worked with them is a way to do their own QA that will show how well did motion correction work, how well did edge correction work. And we built NiiVue into this. So now when AFNI is done running, it will load a web page. And initially, everything's just a fixed bitmap. It's a two-dimensional bitmap that's fixed in, so it loads very quickly. But you can click on the NV button on the web page, and that will make the image become interactive by using NiiVue. So NiiVue will do the visualization for you. And all of a sudden, you can go to the mesh and you can interact with it. And you can adjust different slices and you can look at different locations rather than the fixed slices that are shown in the 2D bitmap. So that's another way that we can actually embed this web technology-based visualization tool for quality control purposes. FreeSurfer is a really popular tool for segmentation, and their FreeView tool is a desktop-based tool. And they've had support from Gates Ventures to bring this to the cloud. And so they've recently released their free browse. And for someone who's used to FreeSurfer, the interface looks very familiar. It has a lot of the user interface elements, but the visualization tool is actually our NiiVue, and it doesn't only recognize all of the formats that FreeSurfer uses, it also recognizes all the proprietary formats that AFNI uses and all the proprietary formats that Brain Voyager uses. So automatically, by using our widget, they're getting support for all these different formats. And I think this also comes back to this question of how complicated or simple a tool is. So NiiVue, the idea is we tried to create a very simple modular tool that you can just plug and play. And so the user interface can be as complicated or simple as you need for the task at hand. So you can think of the user interface really scaling. So from a user's point of view, your motor gestures, your interactions, your familiarity with formats is all built into the module, but the user interface can really match the task that the user is trying to solve. The FSL team's already embedded this with some of their new documentation that describes tools. In this example, it will show brain extraction tool. Initially, it's a fixed 2D bitmap on a web page, but a user can click on it, and all of a sudden they have an interactive web page that they can go through and they can look at the image and see what that image looks like. And then our DG group has created a really nice tool called Tractoscope that allows users to look at Human Connectome Project tractography data from individual participants and really examine each participant and their tracks in their brain using this web technology as the viewing front end for their cloud system. And then already OpenNeuro has become a really popular repository, particularly in North America, for sharing data on on the web, and particularly for us in the US, who are supported by the National Institutes of Health, we're starting to have resource sharing, management and sharing plans that actually require us to share our data. And so it really allows lots of users to look at our data and reproduce our data. But OpenNeuro already embeds NiiVue as a viewer for the data set. So you can interact with the data sets and see what they're like. And here I'm actually showcasing our own aphasia recovery cohort. So one of the things is there's really not that much stroke data that's openly available. And so we try to provide both acute data in our SOUP data set and chronic data in our aphasia recovery cohort ARC data sets on OpenNeuro that allows people to train models in identifying lesions. And I would point out earlier today, Yaroslav gave an excellent talk on BIDS and the underlying format that's behind OpenNeuro. Also, for those of you who have iPads or iPhones or Macintosh computers, you can just go to your app store and you can download a very minimal version of NiiVue that can work offline. It uses WebKit, so it's a standalone application. But it's very compact and it's very fast. And the main interface in it is native to the device that you're using. So that's a first foray into providing NiiVue to the desktop. And then the final kind of NiiVue in the wild taster that I want to give you is something that we're working on. This is definitely a work in progress. And the reason I kind of left off with this is it may speak to a lot of you who feel like this is something you want to contribute. But we are working on embedding NiiVue directly into Jupyter notebooks. And so one thing to think about is that Python really empowers scientists to interact with their data and do things with it. And Jupyter Notebooks is a nice way to document things and make things reproducible. But any visualization that happens within a Jupyter Notebook, the native visualization, has to be using web technologies. And so NiiVue really can be slotted directly into Jupyter Notebooks. And so we already have a basic primitive outline of this working, but we're really trying to make this Pythonic, and so that it has all of the features exposed in a way that will feel very natural for Python users. And that way you can work with meshes and voxels and connectomes and streamlines simultaneously and really see all of those different features coming together. So that's a brief showcase of a few tools that are already using NiiVue. But what I was really hoping to do in this session is also to try to do a little outreach and say, if you're thinking about a project where you're looking for a visualization tool, NiiVue may fit the bill for you. It might be the right thing to use. And one of the things that I really like about NiiVue is our documentation for it. And one of the nice things about the documentation is the documentation doesn't just explain what the commands are and give you an example of it, but it includes live demos where you can say, show me the demo of this command being used. And then you can see the demo and you can look at the page source. And JavaScript, like Python, is a scripting language. And so you can actually edit that source and do different things. So in this example, you can actually create your own color map and apply that. And so you can, the documentation really has that interactivity of you can see how everything works with NiiVue, because the documentation and the web pages are directly designed to work with each other. And the way that I see what we're creating is I see us as creating a recipe book, where if you think about, if you're a developer and you want to use NiiVue in a different project, it's a little bit like a chef who says, I want to make a dinner tonight. And you open up your cookbook and you have lots of recipes that you can see a picture of what that recipe looks like. And then you might want to say, okay, but I like a little bit more cinnamon or nutmeg, and you can change the recipe, but you can start out with this basic recipe that you can start with. And in the same way, we have a very large recipe list of recipes that you can explore and you can try and you can take a look at. And so you can see all of the different very modular, minimalistic implementations that keep you from having a very overwhelming experience of all the different functions you could use. We've had input from lots of developers, and so there are a sprawling, huge number of commands, but we tried to keep all of our demos really minimal and clean, where you can see, this is a problem I want to solve. Here's how I can modularly embed it. And it's worth saying that all of our live demos are done with just pure HTML. So if you are someone who prefers a particular framework like Vue or Angular or React, the raw HTML is really easy to work with. We're neutral to which framework you want to use. So how can you guys contribute? So if you're interested in contributing, we have a GitHub page that you can download everything from, and you can see the recipes. And so again, on the left-hand side here, I'm showing a picture of this is our standard recipe books. So you can see a list of all the different recipe books. And then you can see with each one of these recipes, you can see what it looks like. You can then view the source. And so I would say the first way that you can collaborate is explore recipes. And one thing I want to say, and I'm a huge advocate for open source software, and specifically the licenses we use, BSD, are permissively open source. So that allows private companies, if they want to use our code, they can. It allows GPL to use our code. So my analogy is I like to think about the license we use as O-negative blood. We're the universal donor. No matter who you are, you can use our software. And so that was one of the deals that we made. Both FreeSurfer and FSL have institutional license. I'm actually not allowed to look at FSL code. I'm not allowed to look at FreeSurfer code because it would contaminate the code I write. Whenever they contribute to NiiVue, their developers agree that everything they make is universally accessible. Anyone can look at it. It's truly open source code. And so that means you don't have to worry about it. Whatever project you have, whether you want to create a company or whether you want to create a GPL code, or if you agree with us and you think, I like this idea of a permissive license, you can use our code. The second way that you can get involved with us is communication. And so GitHub has this very nice property called issues, where if you want to see a new feature, or if you find something that doesn't work the way you expect, or if you have advice to us, you can generate a new issue and say, hey, I'd really like to see this specific feature. This is something that we have in another tool, and to try to upgrade our tool with the features that NiiVue has. These are the features you have. And sometimes we'll say, well, we already have that. Or other times we'll say, well, that's easy, that's already on a roadmap. Or other times we'll say, maybe we want to collaborate with you and work on it. But it's a great way to communicate is through the issuing system to get in contact with the different developers. The third way you can get involved is developing. And I kind of briefly show here that to get everything to run, you can simply run these commands from your command line: git clone, then you git clone with this git location, then you change directory to that folder, you install, and you run dev. And the amazing thing is then you get this live page. A web page pops up onto your browser, and as soon as you change the code, the browser window automatically updates with your new code. So it's a hot, reloadable development environment. So this is a really nice way to play with NiiVue, is to just install this. And we have a way that you can then make your own changes in your own fork. And if you want to keep them private, you can. But if you want to share them back, you can generate a pull request and share it with the main community. And if you're interested in this mode, I would really advise looking at the video from earlier today. That's from the MRITogether from Kendra, who really described in detail how you can use Git and how you can really see changes and update changes and push them through. And so that's kind of, I would say, the final way. If you want to contribute code, you can. You can make a contribution to us, and you can share your new fix to the real world. And we always have a bunch of regression tests that make sure it doesn't break anything. And then we also have a manual review from an expert, but it's a very straightforward process for introducing new features and sharing it with the world. So the very final slide I have is our roadmap and our themes. And so we are on a 3-year RF1 grant supported by the BRAIN Initiative, and we're just finishing the first year. And our first year's goal, the word we used was developers. And then the second year goal is users, and the third year goal is cloud. And so what we try to do is really work with the developers to develop a nice set of features to really demonstrate edge applications and API. And our single term for the end of the first year was any browser. And then the second year, we really want to get this to users in Jupyter and through different desktop applications that users can use within a desktop app when they're offline. And we call this our NEOS. And then our third year is really when we're going to bring a lot of these features to the cloud for data sharing and also for federated situations where there are privacy concerns. And so we see that as our anywhere. So that is our 3-year mission. and a little overview of where we are. So thanks for attending, and I'm happy to answer any questions that you have.